This is page 18 in your packet that I am going to show you how to start your practice for today. So we're talking about solving a system by graphing. There are three examples at the top of page 18. They are of a quadratic graph and a linear graph, and there are three possible outcomes. They could not touch and have no solution. They could touch one time and have one solution, or they could touch two times and have two solutions. And those are just some examples of what you're going to see when you graph the ones you're practicing today. So number one says the weekly profits of two different companies selling similar items that open for business at the same time are modeled by the equation shown below. The profit is represented by Y, and the number of weeks the companies have been in business is represented by X. According to the projections, what week did the companies have the same profit? What was the profit of both companies during the weeks of equal profit? So I've come over to Desmos on my computer and typed in the two equations so I could take a look at where they have the same profit. That's the key word in the problem. So that's where they intersect on your graph. So I'm just going to hide my equations and look for the points of intersection. So let's see. Let me bring up a bigger screen for you to look at. If I click home and I drag it around, it's kind of hard to see the red graph that's quadratic, but notice that large number at the end of it is your y-intercept. So it touches at 3,341. So if I zoom way out, it'll start to show up there at the top, and then you can drag it and zoom in a little better on it. So moving your screen around, you can see they do have an intersection down here. And if you click, Desmos is really nice because it'll pop up with a dot that's specifically where they're touching. And your solution would be both of these numbers. So yesterday we were looking at solutions to just an equation, and that is just the x value, but a solution to a system is both points. The x and the y have meaning in this case. So 42 and 2,165 represents the number of weeks that the companies have been in business, and then that would be their profit, and it would be the same amount for both companies. So you could write something like, after 42 weeks, both companies have a profit of $2,165. And you, of course, can write this with a pencil or pen. I'm just trying to show you with my computer. And then I noticed there's another point of intersection. If we drag our graph around, or I should say, it's like go up, they come back together. So it takes a little while to get there. But make sure you explore the graph enough that you find all the points of intersection when needed. So it's way up here at 78, 3,965. So that's another answer to this question, because it asks you, according to the projections, what week or weeks in plural did the companies have the same profit, and what was the profit of the companies during those week or weeks of equal profit? So that is another place where they had equal profit because they both share that same point. So after 42 weeks, the companies had a profit of $2,165, and after 78 weeks, both companies had a profit of $3,965. All right, so that's it for example one. And you would solve most of these problems very similar to that, only slight changes, but sometimes they might just want the x value or the y value, but a lot of times you're asked to find just the solution. So if I type in example 2, 9x minus 6y plus 15 equals 0. Notice I typed an x and a y. I didn't have to solve it for y, which is really nice with Desmos. And then 0.1389 x squared minus 1.25 x plus 2.5. So you're getting some more practice, obviously, with your Desmos typing it in. And it said, what is the y value when f of x equals g of x. So whenever that's a statement, that's just meaning where they have a point or points in common. And then they want the y value. So let's take a look, now that we've typed it in, at what we have on our graph. So now I can see both of them, and I can zoom in here and see that it touches 2 times. Click until it leaves that point on your screen so you make sure you're in the right spot. Sometimes you get close, but you want to be just right. Alright, let me move that over a little bit so I can see. So the y value is actually 2 different values. So when f of x equals g of x, the y value is 0, no, not 0, that's x, is 2.5 and 32.198. So there were 2 different y values because there are 2 places that these two were equal to each other. Number 3, we're just going to type in and find the solution. So just a basic example of solving a system of equations. And the special thing about these is they are not all linear. So the ones you've seen in the past have mostly been dealing with linear functions. So since these can be different looking, you just want to make sure you explore the whole graph and find all the points of intersection that might be there. So don't just think that you found one and you're finished. They can be sneaky. So this graph is right there toward the middle. And I have 2 solutions. So it didn't ask you for x or y, it just asked you to solve, because that's what we're focused on in this section. So let's just write the solution. Let me go down a little bit. The solutions are, and put the whole ordered pair this time. So -1, -3, and 2, 3 are your solutions. And there's just no story involved with that one like there was on example 1. So for your practice problems, you have a variety. The first few are word problems, but they give you the equations, so you just need to type them in and find where they touch and answer the questions with those. The next part of homework is just very much like example 2. Find where they're equal. So you're finding the points where they touch. And then the last part is kind of more of the same, just the basic system problems and listing all the solutions. So just make sure when you type these in Desmos, you find all of the solutions. And then if you have some more time in class, go to IXL and practice Algebra 2, E.16 for some more practice on systems. It's a really good thing to be able to do well and to use Desmos to help you. All right, so that is it for now. Let me see.